Einstein, Newton, Pythagoras, Euclid, Turing. You've probably heard of all these famous mathematicians, but how about ARYBATHA? I bet you've never heard of him. ARYBATHA was an Indian mathematician about 1500 years ago probably, who produced many works on mathematics and on astronomy. There are very many Indian mathematicians. In the case of ARYBATHA, he was more of a theoretician. He wasn't really interested, I don't think, what people thought about his work, so his records were fairly skimpy. You can find more about ARYBATHA on Wikipedia, but ARYBATHA was the man who invented the word sine. Actually, it was initially Yahib, I think that's how it's pronounced, J-A-I-B, Yahib. That's an Arabic letter. But it changed to the Latin sinus, hence sine. And ARYBATHA produced the first sine table. There was actually a difference of signs, but if you read about it, you'll find more about ARYBATHA. Nowadays, we use a right-angled triangle to define sine. We call the angle x and the three sides opposite, O, adjacent, A, and hypotenuse. The other terms are cosine and tangent. We say that the sine of x is opposite or hypotenuse. The cos of x is adjacent of hypotenuse. The tan of x is opposite of adjacent. If you look at a right angle triangle, well, both sides are equal. Using Pythagoras, we can find that the hypotenuse is the square root of 1 squared plus 1 squared, which is root 2. So the sine of 45 is opposite of hypotenuse, which is 1 over root 2. The cos of 45 is adjacent of hypotenuse, which is 1 over root 2. And so they're both 0.707. And the tan of 45 is 1 over 1, which is 1. If we make the angle smaller, then the opposite side becomes smaller and smaller, till eventually it becomes 0, in which case the sine is 0 over something which is still 0. When the angle is 90 degrees, the opposite and hypotenuse are the same value, because that's moved up to here. So the sine of 90 is 1 over 1, which is 1. Similarly, cos 0 is 1, and cos 90 is 0. We could find the value for different angles. We can draw a graph for the value of sine, which will have a shape something like this, in fact, exactly like this, starting at 0, going up to a maximum, down to a negative value, and back up to a maximum, and we get this sine wave. 0, at 90, it's 1, 180, it's 0, at 360, it's 0. At 0 degrees, the cosine is the maximum value. Here we are, there's a cosine wave. At 0, it's maximum. It goes down to a negative, back up again. So there's a cosine wave. Here's the sine wave. If you look here, you see that the cosine wave is going through 0 before the sine wave. So the cosine leads the sine wave by 90 degrees. For the tangent, when the angle is small, the value of the opposite divided by adjacent is small, so tan 0 is 0. When the angle is large, the adjacent side is very, very small, tending towards 0. So the sine of 90 is opposite over 0, which is a big number, infinity. And here we have the graph showing how there's 0 degrees as it starts to increase rapidly and shoots away to whatever infinity is. And that's the graph of tangent. these are things I produced for my great-granddaughter. She's, at this time, she's probably not going to be able to use these, but she will do in a year's time, probably. So I always give her some questions. The first use of sine was by a Roman mathematician. Is that true or is it false? What was ARYBATHA's age when he died? We can find that by looking at when he was born and when he died. And finally, I think, oh no, not finally, the problem here, using the equations, find sine theta, cos theta, and tan theta. The final question is, same sort of thing really. When finding the height of a building, an instrument called a theodolite is used to find theta. In this case, it was measured at 45 degrees and it positioned 25 meters from the building. So what was the height of the building? Not difficult questions. So that's a very short idea about sine, cosine and tangent, really mainly to show you who first about sine. A very, very clever mathematician who I'd never heard of, and I don't suppose you had either. Bye.